Let's start ionic equilibrium one shot video. I already covered one shot video for chemical equilibrium. So in this, first substances are classified into these types: electrolytes and non-electrolytes. Electrolytes which dissociate into ions, non-electrolytes which doesn't dissociate into ions. Based on the degree of dissociation, we can segregate electrolytes into two types: strong and weak. Strong electrolytes where alpha value is 1, weak electrolytes where alpha value is less than 1. So generally all strong acids, strong bases comes under strong electrolytes, and weak acids and weak bases comes under weak electrolytes. Coming to non-electrolytes, where the dissociation doesn't occur, means alpha value is equals to 0, like non-polar compounds like urea, glucose, fructose, etc. So based on conductivity, substances are classified into two types: conductors and non-conductors. Where the electricity pass through it is called as conductors, where it doesn't conduct electricity called as non-conductors. These conductors again segregated into two types, that is metallic and ionic. Metallic conductors is nothing but metallic conductors are also called as electronic conductors, where the conductivity happens through flow of electrons. So in this case, temperature increases, resistance increases, so conductivity decreases, because when we increase temperature for the metals, the electrons will vibrate instead of flow, so that metallic conductor decreases conductivity power over increasing temperature. So coming to electrolytic is nothing but the conductivity happens through ions, so that it is also called as ionic conductors. When we raise the temperature, the dissociation of ionic compound increases and conductivity increases. So these are some of examples for strong electrolytes and weak electrolytes. So strong electrolytes are all the strong acids, and all the type of salts also comes under strong electrolytes. These are strong bases except all alkali metal hydroxide and barium hydroxide. Weak acids and weak bases are required to memorize. So H2CO3, HClO2, HNO2, and all oxy acids of phosphorus, and also some of the carboxylic acids. All organic acids are weak acids: HCN, H2CO3, H3BO3. So here Hi is strong electrolyte, but HF is weak electrolyte. Similarly, all alkaline earth metals except BaOH twice and AlOH thrice and NH3 and D block metal hydroxides. This is just a basic one. Now we will start discussion of theories about acids. Acid base theory. There will be three theories here: Arrhenius theory. So let's complete Arrhenius theory first. So Arrhenius theory explains based on the proton and hydroxide ion, the substance which contain replaceable H plus ions is called as acid in solvent. The substance which contain replaceable OH minus ions is called as base. In simple words, which produce proton is called Arrhenius acid in solvent, which produce OH minus ion in solvent is called Arrhenius base. Example for this: anything which contain HCl, and here CaOH twice, NaOH, all this. Similarly, second theory is Bronsted Lowry's theory. Bronsted-Lowry's theory. Here acid is nothing but which donate H plus ion or which contain replaceable H plus ion without solvent. Bronsted base is which accept H plus or proton is nothing but Bronsted base. So in simple words, H plus donor is called Bronsted acid, H plus acceptor is called Bronsted base. So example for this, same like first one, and here NH3 which ready to accept H plus from outside because of lone pair electrons. So here one more concept we can discuss, conjugate acid base theory. Conjugate acid base pair. So what does it mean? Let us take HCl. After loss of HCl we get Cl minus. So this is acid, this will be conjugate base. Same way NH3 is base. After accepting H plus we will get NH4 plus. So the pair which differed by one H plus ion is called as conjugate acid base pair. And always strong acid produce weak conjugate base, weak acid produce strong conjugate acid. So weak acid produce strong conjugate base and vice versa. So same way weak base produce strong conjugate acid, as like that. So this is about conjugate acid base pair, and generally questions will be like this: what is conjugate acid of X? Suppose, then what you can do is just we have to add H plus to that. So you take example H2SO4. If you take, what is this is acid that we know. If they ask what is conjugate base of H2SO4, we can write HSO4 minus. So this is conjugate base, and for this conjugate base is SO4 minus 2. So this is called as amphoteric species. It behaves both acid as well as base. So what we have to do, just if they ask conjugate acid of anything, we have to add H plus. If they ask conjugate base of something, we have to subtract H plus from that. So that is how we can write it. Conjugate acid means just add H plus. Conjugate base means subtract H plus. That's all. Subtract H plus. So this is about conjugate acid base pair and related Bronsted theory. Coming to next, Lewis theory. So Lewis theory is nothing but Lewis theory means Lewis acid. What is Lewis acid? Gain of electrons is nothing but Lewis acid. Example AlCl3, generally which doesn't have 8 electrons in its outermost shell, behaves as Lewis acid. Or incomplete octet compounds behaves as Lewis acids, or where the empty orbital is available that ready to accept electrons and behaves as Lewis acid. So the substance which accept a pair of electrons is nothing but Lewis acid, a pair of electrons. Lewis base means which ready to give a pair of electrons. Ready to give a pair of electrons is nothing but Lewis base. So Lewis acid plus Lewis base together will give coordinate covalent bond. Coordinate covalent bond. So Lewis acid plus Lewis base gives coordinate covalent bond. These are the theories about acid and base. Now we are going to discuss pH calculation. Very important from now. So pH calculation, what exactly it is? So H2O is weak electrolyte, so it dissociates very less at room temperature. So just 10 power minus 7 molarity of H plus and OH minus ions are released. So for this, in the place of H3O, H plus, we can write H3O plus. So we can write that same equation, H2O converted into H plus plus OH minus. So 10 power minus 7 molarity or mole per liter. So you can write it as equilibrium constant equals to H plus by OH minus by H2O. So product by reactants. So KH2O we can write it. So KH2O equals to H plus into OH minus. Now this KH2O we can write it as ionic product of water. Is always H plus into OH minus. So that from this only we can write the formulas related to pH. So pH equals to negative log H plus and pOH equals to negative log, here base 10 will be everywhere, OH minus. But in this case, if we increase temperature, the Kw also increases. Here KH2 we can write it as Kw. So temperature increases, dissociation of water increases, so that Kw or KH2O will increase. How to find in this? pH pH plus pOH equals to always 14. Then here two cases are very important. Case 1, suppose if strong acid or strong base is given. Strong acid or base is given, then how to do is, if H plus ion concentration is greater than or equals to 10 power minus 6 m. If the H plus ion concentration is 10 power minus 6 m, so if H plus ion is greater than or equals to 10 power minus 6 m, then we can directly take, then if H plus ion concentration is greater than or equals to 10 power minus 6, then we directly take the H plus ion concentration whatever given in the question to find the pH. Example for this, find pH of 10 power minus 3 HNO3 MHNO3, then pH equals to negative log whatever is given here, that itself we can substitute 10 power minus 3. And what is the result, students? It is like negative log of a power minus x, means we can take it as, you can write 10 power minus x, so it will be plus x, because log 10 base 10 is 1, so you will get x, because x log base 10 you will get, this value is 1, so that x only will get, minus into minus plus. But case 2, if you see, if H plus ion concentration is less than 10 power minus 6 m, then we can use other way to calculate pH. Let's find the pH of 10 power minus 8 mHCl. Then what is the result, students? Here H plus given is 10 power minus 8, pH equals to negative log base 10 10 power minus 8, we can take it as plus 8, which is wrong answer, because if H plus ion concentration is less than 10 power minus 8, we cannot do this way. What we have to do is, we have to take water H plus ion concentration also. H plus net value equals to H plus from acid plus H plus from water. So 10 power minus 8 plus 10 power minus 7, which is from water. So H plus 10 power minus 8, if you take common, 1 plus 10 you can write it, which can be written as what? 11 into 10 power minus 8. So for this, pH equals to what? Negative log of 10 power minus, negative log of 11 into 10 power minus 8. If you take, what formula we can substitute here? pH equals to what? You can write negative log 11 into 10 power minus 8, means we can write it as negative log base 10 11 plus negative log minus negative log into 10 power minus 8, which can be written as 8 minus log 11. Then log 11 is nearly 1.1, so that 8 6.9. This is the answer if H plus ion value is less than 10 power minus 6. So hope it is clear. Coming to next, different cases. Case 2, pH of mixture of 2 strong acid and strong base. So if you add 2 acids or 2 strong bases, then we can write this formula: N1V1 plus N2V2 by N1V1 plus V2. Just it is normal mixture of strong acid and strong base. Suppose H plus, if you want, you can do this way. OH minus means you can do other way. So here, if you want to write molarity form, suppose molarity is given, normality is nothing but what? Molarity into n factor, that we can substitute if molarity is given. So M1 V1 n factor 1 plus M2 V2 n factor 2 by V1 plus V2. Here, if 2 strong acids are given, we just take plus sign, just we will add either 2 strong acids or 2 strong bases, then we will just add it. Suppose if one is acid, another one is base, then what we have to take? We have to take minus, means the resultant, how can we do is, just we have to subtract, and the resultant is the H plus or OH minus ions. Hope it is clear. Now coming to case 3. So pH of weak monobasic acid. This is formula like one shot video, so if you want full detailed manner. You can watch the complete chapter videos. Weak monobasic acid or monoacidic base. This is called as Oswald dilution law. So for weaker acid or weaker base, pH value calculated with Oswald dilution law. This is most important. This is only repeated in electrochemistry also. HA converted into H plus plus A minus, and we can take concentration and time is 0 or initial, so this will be 0 0. After some time C alpha C into 1 minus alpha we can write it for this. So what we can write is Ka equals to, or equilibrium constant equals to H plus into A minus by HA. So that we can substitute here C alpha into C alpha by C into 1 minus alpha. So you will get C alpha square by 1 minus alpha, which is Ka value. Here alpha value, if alpha is less than 5%, then 1 minus alpha take it as 1 only, because alpha becomes very less. So Ka equals to C alpha square, 1 minus alpha you can take it as 1. So this is the formula which we get. From this alpha, what we can write? Ka by C under root. So C we can write it as number of moles by volume. Suppose if n equals to 1, alpha we can write it as Ka into V. So this is about alpha. Now from this H plus given as H plus, we can take it as C alpha, so that H plus equals to C alpha means C into under root Ka by C. So if you write this, Ka into C we can get C square by C, that we can write it as under root Ka into C. So from this we can get pH formula also. pH negative log of H plus, right? So in the place of H plus, negative log Ka into C whole power half. So from this only we can get pH equals to half into pKa minus log C. This is the formula which can be used to find the H plus for weak acids. So pH for weak acids. So here DOD of weak electrolyte is inversely proportional to square root of concentration. So alpha is inversely proportional to square root of concentration, and also alpha is directly proportional to square root of volume. These are the two formulas which we derived from above. Next, coming to case 4, pH of polybasic acid or polyacidic base. So if you take H3PO4 over splitting, it will give H plus plus H2PO4 minus. You can take it as Ka1, and same way H2PO4 minus converted into H plus and HPO4 minus 2. This is Ka2, and similarly HPO4 minus 2 converted into H plus plus PO4 minus 3. So this is Ka 3. So from this we can write the summarized formulas. So alpha equals to under root Ka 1 by C, which is same as Oswald dilution law formula. H plus equals to under root Ka1 into C, so which is nothing but H2PO4 minus concentration. So this conjugate base concentration is same as normal Oswald dilution law, and pH equals to half into pKa1 minus log C. And coming to second formula, this is for first, this one only. Coming to second formula is, you can write it that in the next page. So HPO4 minus 2, you can write it as Ka2, and PO4 minus 3, we can write it as Ka2 into Ka3 by H plus concentration. So this we can get it from the above formula, and that can be substituted in this formula to get PO4 minus 3 concentration. This is just Ka2 formula. So these are about where weak polybasic acid or polyacidic base is taken. Coming to next case, case 5. These all cases are very important. They can ask from anywhere. So pH of mixture of two weak acids or two weak bases. So H plus, you can write it as under root same Ka1 C1 plus Ka2 C2. Oswald dilution law only for this one. So here C1 and C2 are concentrations after mixing. So OH minus also same way we can write it, under root Kb1 C1 plus Kb2 C2. So this is for weak bases. This is for mixing of two weak acids. So coming to next, case 6. So pH of mixture of weak acid and strong acid. This is little different and a little complex formula. Weak acid C1 Ka1, strong acid C2 Ka2, but not required this. So H plus equals to minus C2 plus or minus under root C2 square plus 4 Ka1 and C1 whole divided by 2. This is the formula for finding H plus overall if you add weak acid and strong base. Coming to next most important, case 7. So pH of amphiprotic species. Let us take HCO3 minus is the amphiprotic species. It accepts H plus and become H2CO3. It lose H plus and becomes CO3 2 minus, so that it behaves as amphoteric oxide, amphiprotic species. So pH equals to pKa1 plus pKa2 by 2. This is for this one only. This is Ka1, this is Ka2. Suppose if it is this one, if the HPO4 minus 2 is there, just a minute. You can write H3PO4 loss of H plus and converted into H2PO4 minus, further loss of H plus converted into HPO4 minus 2, further loss of H plus converted into PO4 minus 3. If you here two are the amphiprotic species, one is this one, another one is this one. So for this one we can use this formula, because this is Ka1 value, this is Ka2 value, this is Ka3 value. If you want pH of H2PO4 minus, we can take it as pKa1 plus pKa2 by 2 average. Similarly, pH of HPO4 minus, if you want, then you can write it as pKa2 plus pKa3 by 2. This is the formula for pH of the respective ions. So these are the formulas related to these things. So questions mostly ask here, and polybasic acids are polyacidic base and Oswald dilution law. These are the related formulas for pH calculation. Let's start. Salt hydrolysis is the next. Salt hydrolysis. Salt hydrolysis is nothing but reverse of neutralization process. During salt hydrolysis, we get either solution is acidic or basic or neutral. That depends on the type of salt which we use to make hydrolysis process. In simple way, if you take a salt of weak acid plus strong base, that is CH3 COONA. This is formed from weak acid CH3COOH and strong base NaOH, so that it is basic salt. So this basic salt over hydrolysis, the reaction happens like this. We'll get CH3COOH plus OH minus. That means the resultant is OH minus, so that it is called as basic solution. The solution pH will be more than 7. Why this is formed as CH3COOH? We already know that weaker one always stable in molecular form, so that this is stable. The resultant OH minus ions in the solution and considered as basic solution. So in this, which ion participated in the hydrolysis from this salt? Anion is participated in the hydrolysis, because high reactive ions are stable in the ionic form. Means Na is stable in Na plus form, so it won't react with water. It will become as Na plus only. So that then weaker ion combines or accept respective ion from water and get neutral product as like this, which is CH3COOH here. Since anion participated from salt in the hydrolysis, it is called as anionic hydrolysis. Coming to next, KH equals to under root KH into C. KH equals to, that is called as hydrolysis constant, which is Kw by Ka. Then degree of hydrolysis, which is alpha. Sorry, earlier we indicate with alpha, but here we indicate with H. H equals to under root KH by C. So pH formula is, everywhere we get resultant solution, right? Either acidic or basic or neutral sometime. So to find that pH of solution, we use this formula. In this case, pH equals to 7 plus half into pKa plus log C. Why we are taking 7 plus? Because here the solution is basic, so it will be more than 7, so that we are taking 7 plus. Very important formula. And pH is more than 7, so that the solution is basic solution. This is for first one. There will be derivations for all these. Those derivations not required for normal questions. so that we can remember only formulas for solving questions. Coming to the second model, strong acid with weak base, salt hydrolysis. So in this case we take NH4Cl is the salt, because here NH4OH is the base and HCl is the salt. Together we'll get this. So this is weak base, and this is strong acid. So together we'll get NH4Cl. It is in this NH4 plus combines with water and get NH4OH plus H plus. So this is KH. Here what will be the result, students? This is weaker ion that is coming from salt, that is cation. Combines are hydrolyzed with water and becomes NH4OH and H plus. Since the resultant is H plus, the solution is acidic. pH is less than 7 and acidic. So in this case, which ion is participated in hydrolysis, students? Cation is participated in hydrolysis, so that it is called as cationic hydrolysis. And then KH equals to KW by KB, and then H equals to under root KH by C, and pH value is 7 minus, because it is acidic solution, pKb plus log C. So the same kind of formula we used in Oswald dilution law, but there it will be minus, here it will be plus. So coming to next, here pH is less than 7, so that acidic solution. Coming to the next third model is weak acid plus strong base, salt hydrolysis. So example for this, CH3COO NH4 . Sorry, this is let's start next case, that is weak acid plus weak base, salt hydrolysis. So here both are weak, so weak acid is CH3COOH and weak base is NH4OH. So these together undergo hydrolysis and get CH3. These are double headed arrow mark because it is unstable, like reversibility possible, NH4OH. Since no resultant ion is possible in this, and also both anion and cation undergo hydrolysis, so that we can take this hydrolysis is anion and cation both hydrolysis. We can take cationic and anionic hydrolysis. And coming to KH equals to KW by, here both are taken, so that Ka into Kb, just sum of the first two, nothing else. Here H equals to under root KH by Ka into Kb. So next is H equals to under root KH, because this hydrolysis doesn't depends on concentration of salt. So DOH doesn't depends on concentration of salt. Why? Because these are weaker. It doesn't matter what is the concentration of weak ions. It is ready to hydrolyze, it will, otherwise it won't. So that the concentration of salt doesn't matter in this. So finally, what is the formula? pH equals to, very important this formula, pKa finally the important formula, it is so this is very important formula. So we can write pH of this weak acid weak base salt hydrolysis equals to 7 plus half into pKa minus pKb. Very important, multiple times question came from this. So this is the important formula for both JEE and NEET. So these are the salt hydrolysis first three models, and coming to last, that is salt of strong acid plus strong base doesn't undergo hydrolysis because both are strong ions, means both are not undergo hydrolysis with water, so that pH is always 7. So these are the important formulas which related to the salt hydrolysis. So here which kind of questions possible to ask is, they give salt and tell what is the pH of the resultant salt over hydrolysis, or directly the above formula related questions. Coming to next concept is questions, I will do separate video students. So just for formula purpose, I have formula and conceptual purpose this video I am making. So buffer solution, so the solution which resist the change in pH by adding small amount of strong acid or strong base. The solution which resists the change in pH even though we add small amount of strong acid or strong base is called buffer solutions. So these buffer solutions are two categories, simple buffer and acidic complex buffer or mixed buffer. So this simple buffer is just salt of strong base with, so simple buffer is nothing but salt of weak acid with strong base or weak base with strong acid. So example for this CH3 COONA and this one NH4Cl. But complex buffers are categorized into two types, acidic buffer and basic buffer. So acidic buffer means CH3, the composition first will write. So weak acid plus salt of weak acid with strong base. Same way basic buffer is weak base plus salt of weak base with strong acid. The compositions, if you see, this one is CH3COOH plus this CH3COONA, and same way NH4OH plus NH4Cl. These compositions we can tell it as acidic and basic buffers. Now how the buffer action takes place. Suppose you take CH3COOH. For this, if you add little amount of, like we can write mechanism buffer action. So here, if we add acid, the CH3COO minus from this salt accept H plus and becomes CH3COOH. That means the added H plus neutralized. Same way, suppose if they add base CH3COOH, from this take OH minus and become CH3COO minus and H2O. So whatever added OH minus is there, that becomes H2O, means neutralized. Whatever H plus is there, that will neutralized with salt ion of CH3COO minus. Similarly for this, if you take same thing, NH4OH accept H plus, added H plus and neutralize, becomes NH4 plus and H2O. And same way, NH4 plus of salt ion, this one, because salt is having more dissociation, so it will take OH minus ion from the added part and becomes NH4OH. That is how the added H plus or added OH minus ions neutralize. That is nothing but buffer action of acidic and basic buffer. Most important is how do we prepare these buffers. Acidic buffer can be prepared by these ways or three ways. Most important questions were asked from this area only. The first one is normal, so CH3COOH plus CH3COONE. This is the normal way to get this. This is called as weak acid and salt of strong base. Coming to next, here only questions possible to ask more. Weak acid is mixed with strong base. Number of moles of weak acid supposed to be greater than number of moles of strong base. So we can take CH3COOH plus NaOH converted into CH3COONA plus H2O. Suppose if you take 10 moles of this initially and this one is 5 moles, and what will be the salt formation based on the limiting reagent. So based on limiting reagent, 5 moles of salt will be formed and 5 moles of acid left out. So because 10 moles we are taking, 5 moles of base we are taking, here N factors are remains 1 for acid and base. So only 5 moles of acid combines with complete 5 moles of NaOH and get 5 moles of salt. So here after reaction we get 5 moles of acid and 5 moles of salt. That is nothing but buffer solution. So the rest will be 0, 0, and it doesn't matter whatever is formed. Suppose here what you will get is 5 moles only. So this is how we can get the buffer, because buffer is nothing but what, weak acid and salt of weak acid with strong base. So that's how we can get this one. Coming to next way to prepare salt of weak acid plus strong base with strong acid. So here condition is number of moles of salt should be greater than number of moles of strong acid. So here these are called as initial moles, students. You can see the reaction. CH3COONA is the salt of weak acid with strong base plus, and HCl is the strong acid, split into CH3COOH plus NaCl. So in this case initial moles Ni 10 moles and here 5 moles and 0 and 0. So moles after reaction what you will get is, here N factors are 1 1 only, Since 5 moles of strong acid we took, so complete 5 moles react with CH3COONA according to limiting reagent concept. So resultant moles after reaction is 5 moles of this one, this will be 0, and this also 5 moles we will get, right? And this also 5 moles will get. But here this is the weak acid, this is the salt of weak acid, both are there in this. So that is how we can get the buffer. These are the ways to prepare buffer solutions. Hope it is clear. Now coming to endurance equations are the calculation of pH buffer solutions. Everywhere this pH will be common because everything produce some sort of acid or basic solution. Calculation of pH of buffer solutions. So here directly we can write the formulas. pH equals to pKa plus salt by acid. So here salt we can tell it as conjugate base. Generally CH3COO minus considered as conjugate base for problem solving. That depends on the acid which they give. So POH equals to pKb plus log base 10 and conjugate acid by base. These are the related formulas for pH and POH. Accordingly we can calculate the solution pH during buffer problems. Then there is one more thing, that pH minus pKa equals to log base 10 conjugate base by same thing. What we did is just we shifted this pKa this side by acid. Here what kind of questions possible to ask? Sometimes they ask pKb, sometimes they ask POH, sometimes pH, and sometimes this also, because this concentration we can write it as molarity into volume. Next one, buffer range. Most of the questions linked to buffer only in this chapter, and solubility product, common ion effect, such questions. Buffer range is nothing but 1 by 10 greater than or equal, sorry, less than or equal to conjugate base to acid less than or equal to 10. So pKa minus 1 less than or equals to pH and less than or equals to pKa plus 1. This is buffer range. How better it is, controls the pH of solution or resists the pH of solution. Coming to next, buffer capacity. So buffer capacity is nothing but number of moles of strong acid or strong base added per liter solution to change in pH. Change in pH buffer is nothing but buffer capacity. So these all are the related formulas for buffer and related derivations and related things for buffer. So these are very important. Coming to next, is solubility product and solubility. Maximum number of moles of dissolved solute in solubility is nothing but maximum number of moles of solute dissolved in a solvent to obtain 1 liter solution. So solubility units are generally mole per liter, sometime gram per ml also they ask, sorry, gram per liter. If they ask in gram per liter, then what you have to do is mole per liter into molecular mass, because mole into molecular mass is the mass of the salt which is given. So relation between Ksp and solubility and ionic product also, that we can discuss. First we will complete this two. This is very important. AXBY split into XA y plus y b x minus so the electrolyte is AXBY is there. So let us take here X ions means X solubility is formed, here Y solubility is formed. So Ksp is a mathematical representation which can be written as X is power X, Y is power Y. The coefficient should write at powers. So X power X into S power X, Y power Y and S power Y. What we can write here? So Ksp equals to X power X into Y power Y and S power X plus Y. This is the way to represent Ksp for any electrolyte, sparingly soluble electrolytes. Suppose if you take example of AB electrolyte like NaCl, what you can write it? NaCl split into Na plus and Cl minus. So here S, here S. Generally sparing soluble salts are given. Here nothing is there, so that S power 1 into S power 1, which can be written as S square. So like that we can write different things. BaSO4 if you take, what you can write, it will split into Ba2 plus SO4 minus 2 and S into S square equals to Ksp. Same way NH4 twice SO4, so here split into NH4 plus 2NH4 plus SO4 minus 2, so 2S into S, but Ksp here you see carefully, S power 2 into S power 1, which can be written as 2S whole power 2, so that 4S cube, as like this. But here some of the important points, Hz to Cl2 will split as like this, Hz2 plus 2Cl minus, so that S into 2S, so Ksp value is 2S whole power 2 into S power 1, which is nothing but 4S cube. Like that different examples we can take to decide solubility product. So K3 PO4 if you take, it split into 3K plus PO4 minus 3, so 3S into S, so Ksp equals to 3S whole power 3 into S power 1, which can be take it as 27 S power 4. So that's how the questions the solubility and this relation. Questions, many models will be under this. I will discuss questions in the next short video. So this is just for concept purpose and formulas related to that, and you can also write some more formulas. Ionic product and Ksp relation, So ionic product, it is greater than KSP, that is super saturated solution, means precipitated will be formed, and ionic product less than KSP, it is unsaturated solution, and ionic product less equal to KSP, saturated solution will be formed. Then last concept is common ion effect, and indicators also we can discuss, but that we will discuss in the next video. This video length already reached to maximum. Common ion effect is just decreasing the dissociation of weak electrolyte. So common ion effect is nothing but decrease in the dissociation of weak electrolyte by adding strong electrolyte which contain common ion with weak electrolyte. So what is it? I will tell you. Just take sparingly soluble salt AgCl, split into Ag plus and Cl minus slightly, since it is sparingly soluble salt. Suppose if I give you strong electrolyte, this is called as weak electrolyte, and strong electrolyte is NaCl, where Cl is common in both. So NaCl, Na plus and Cl minus. So here strong electrolyte split completely, so that we will put normal arrow mark. Weak electrolyte is partially, and it is reversible also, so that double headed arrow mark. So when we add strong electrolyte to weak electrolyte, the dissociation of weak electrolyte or AgCl decreases due to strong electrolyte ion. What is it? Here both the cases Cl minus is released. That Cl minus ion increases in the solution mixture that easily combines with Ag plus and form AgCl. What does it mean? According to Le Chatelier principle, if product concentration increases, backward reaction is favorable, so that AgCl stable in molecular form. So formation of AgCl is keep on increases. That is indirectly telling that dissociation of AgCl or weak electrolyte decreasing. That is nothing but common ion effect. Suppose if I give you 0.1 m strong electrolyte or NaCl, so to find the KSP value, we just take KSP of AgCl equals to 0.1 plus, here S will be taken, right, for AgCl. So S, this is for what ion? Cl minus ion, and S is for Ag. But this S is very less as comparatively 0.1. So we will take 0.1 power 1 S power 1 equals to KSP of AgCl. That is how we can find KSP value of weak electrolyte when we mix with strong electrolyte or when we make common ion effect. So there are many things, not only for this, even pH also decide the correct KSP value for the weak electrolytes. Hope it is clear, students. So this is what overall what is the ionic equilibrium chapter complete formulas, and please like and subscribe completely or in detailed way the ionic equilibrium and chemical equilibrium. Thank you.